So we're looking at second order differential equations now, and they're called second order because we're differentiating, or we've got a second order derivative here. Two dashes, we could write it like that, or as d squared y dx squared. So here when we're solving these equations, the way in the textbook that you're shown to solve these is by using a substitution, by letting p equal dy dx, and then if you differentiate p, you'd have the second derivative. So what that means is you can make a substitution with p, solve this differential equation, and then once you've found what p is, you then integrate, because you'll then find what y is. Integrating p is the same as integrating dy dx. The way I'm going to show you here is just a bit simpler. I think it's just easier to integrate twice here. The reason for that is if you integrate y dash, we know that we get y. So if we integrate y double dash, we know that we get y dash plus constants. So if we integrate the second derivative once, we'll get the first derivative, and then we integrate it again to get y. So all we're going to do is integrate this right-hand side twice. So we'll look at A. We're going to find the general solution. So remember, this is going to have constants. And the big thing with this is because we've got a second order differential equation, we're going to have to integrate twice. And what that will do is it's going to introduce two constants of integration along the way. So we're just going to call those usually C or D or AB, doesn't really matter, just make sure that they're different things. You can call them C1 and C2, I'm going to call mine C1 and C2. So first thing I'm going to do is write down my differential equation. So second order, 10x cubed minus 3x plus 4. I'm going to integrate both sides. And I know that when I integrate the left side, I will get the first derivative. And that's because we're integrating the second derivative gets the first derivative. We then integrate the right-hand side. So I'm going to get 10x to the fourth on 4 minus 3x squared on 2 plus 4x, we're integrating with respect to x, plus c. I'm going to call that C1, my first constant. So that's the first level of integration. Now I'm going to, and I'll do this in different colours so you can see, I'm going to integrate both sides, again. If I integrate the left side, I'm integrating the first derivative, and that gives me y. So I'll get y equals, now I integrate the right-hand side. So we're integrating all of this, dx. Often it's a good idea to simplify before you integrate. So you can't simplify 3 over 2, but if we divide the top and bottom here by 2, you'll get 5 over 2. Integrating, we get 5x to the 5 over 2, and then the power comes underneath, minus 3x cubed on 2, and the power comes underneath, plus 4x squared on 2, and it doesn't fit, I'm just going to move this over so it will fit. The constant here in our original integration now becomes a coefficient of x, plus, I might do it, move it over a little bit more so you can see. So that was our first constant of integration, and then our second constant of integration gets added on at the end, c1x plus c2. So we can simplify, therefore we get y equals 5x to the 5th over 10, Or if you wanted to, we could straight up just do some cancelling here, get rid of the 5's, get rid of the 3's. That's a bit easier. Do that again. So we've got x to the 5th over 2 minus x cubed over 2. 4 divided by 2 is 2, so that's 2x squared, plus c1x plus c2. And this is where c1 and c2 are constants. And this is our general solution. The reason it's a general solution is that you've got the constants still there in your equation, and you haven't solved for a particular solution or particular values of x and y, so that's our general solution. If we have a look at the other ones, I'll put this just onto the next page. These ones are a little bit shorter. So we look at B. again we've got, just write out the equation and integrate it once, so we get dy dx equals the integral of cos 3x, which equals sine of, and I'll just write it underneath, that's going to be sine of 3x over 3 plus a constant, we'll call it C1. Next step, integrate again. So this is int both sides. It's usually a good idea just to write what you're going to do. And again, we're going to integrate both sides. So we get y on the left side, and then we integrate sine of 3x on 3 plus c1 with respect to x. So we then get, therefore, we're going to have y equals, the integral of sine is negative cos of 3x. It's already over 3, and then we have to divide by the 3 again, plus c1x plus c2. So that means our general solution is y equals, and it's going to be negative 1/9 of cos 3x plus c1x plus c2. And it's always a good idea just to write c1 and c2 are constant. Cool. So c is pretty similar, and you've got e to the negative x. Integrating both sides. And this is a nice place to stop the video. See if you can finish these off. E to the negative x divided by negative 1, because it's the derivative of the power that you divide by, plus c. Int both sides again. I've just left out the step where I've shown the integration here, so I'm just doing the integration. E to the negative x on negative 1 times negative 1. I'll call that c1 plus c1x plus c2. The negatives will cancel each other out there, so that means that we now have a nice general solution. Just delete this part and bring this over so we can do our last one. So our general solution for that one is going to be y equals, and it's e to the negative x plus c1x plus c2. And it's a really nice, there we go, idea at this point, just because that's quite an interesting one. I'm just going to differentiate this twice here, just as a check, just to see what this looks like. Differentiate it the first time, we get negative e to the negative x plus c1. Differentiate it a second time, negative comes out the front, we get e to the negative x. The constant disappears. And that's what we started with, which is awesome. So the last one is d. And I'll just move it over here and copy out the question. So again, it's the same thing. They're all pretty similar. So we've got d squared y dx squared equals 1 on the square root of x plus 1, which you could write as x plus 1 to the power of a half. Okay, so negative a half. So we're going to integrate both sides. So we're going to get dy dx equals, because integrating the second derivative gives you dy dx, the integral of x plus 1 to the negative a half, which equals x plus 1, add 1 to the power, which will make that positive a half, divide by the new power, and also divide by the derivative of the bracket, but we know that that's just 1, so that won't change anything, plus c1. And I'm just going to simplify that, so we have, because we're dividing by a half, it's the same as multiplying by 2. So it would be 2x plus 1 to the half plus c1. And again, we're going to integrate both sides. So that's going to give us the y on the left side. And integrating 2x plus 1 to the half plus c1 with respect to x will give us 2x plus 1, add 1 to the power, which makes it 1.5 or 3 over 2. Divide by the new power. C1 is now a coefficient of x, and we have the new constant C2. So that means we now have y equals, this 2 will come up, so it's going to become 4/3 of x plus 1 to the power of 3 over 2 plus c1x plus c2. And that is the general solution for our DE, where c1 and c2 are constants. And there are constants of integration. So the main thing here really with the second order differential equations, integrating 2 times, integrating once to get dy dx and then integrating a second time, and remembering that for the general solution you'll now have 2 constants of integration.